If you live in some countries, you might be familiar with the grade point average, or the GPA, or you might have just heard of it from media. It's basically just an average that represents your grade. In the US, before calculating the GPA, we first discretize each class grade into the form of letter grades. We then assign a value to each letter, add them up, and average it to get the GPA. Since a lot of parents want their kids to be straight A students, many people shoot for a 4.0. But after we're through, you might be able to pass by with mostly B's if you're precise enough. To calculate pi, we'll want to find each letter grade required that will average as close to pi as possible. We'll never find a combination that gives us exactly pi, however, since pi is irrational, meaning it can't be represented by a fraction of two integers. The most straightforward approach is to just go through every combination and record the best result for the end. Let's make this in Python real quick. This is taking a while, so as we wait, let's see how many possible combinations there are. We have 10 different possible grades for 40 total classes, so that gives us 10 to the 40th power combinations. So obviously the brute force approach is horrible, but there's a few things we can do to try to speed it up. First, let's switch to a lower level language. I'll do Rust. Also, floating point math is slow, so we can switch most things to work in integers. Next, we don't care about the order of the grades, so an A and a B is the same as a B and an A. Really, all we care about is the total amount of A's, B's, etc. This is called stars and bars. First, we create a letter grade enum and represent each variant with 10 times its real value to keep everything away from being floating point. Then we can make a struct that maps each variant to the amount of classes with that grade. We'll use the create enum map for this and have letter grade derive its enum trait. We can also just derive debug on everything from now on to make debugging easier. Also, since grade counts is a wrapper type, I'm going to implement deref and deref mute just to make using it easier. Since we are going to want to iterate through each variant of grade counts, I'll make this struct that will implement iterator. It will hold its own version of grade counts that it will modify on every iteration. It will also need to hold a flag to know whether or not it has started iterating yet. We'll use this flag to initialize it on the first run. Here I'll also make these two const for convenience. Now we need to figure out how to algorithmically go through each possible combination. Let me explain it by giving an example with only 4 possible grades. We'll start with all 40 classes getting the first grade. We then start from the right, skipping the last item, and move left until we find a value that is not 0, and call this index I. When we find I, we subtract 1 and add 1 to the value at index I plus 1. We then move the value in the last class and add it to the value at index I plus 1. We are basically sweeping each class left to right while making sure to encounter all possible combinations of arrangements. The first thing I want to do is iterate through each grade from right to left, skipping the last grade like we did in the example. We can derive strum's enum iter on letter grade, which will give us an iterator over each enum variant, and then run the rev method to reverse the order to go right to left. Also, because we will often need to do things to the following grade value, we'll do a sliding window of every contiguous pair using tuple windows from iter tools. What's a little confusing is that because it's going right to left, the first value returned is actually the value after the one we want to be pointing at. The first step is to find the rightmost non-zero value and subtract 1 from it. Because all the values are unsigned integers, we can just do a checked subtraction and continue through the loop until 1 does not return none. Once 1 is found, we set the value of the next one to the last value plus 1. However, before we reset the last value to 0, we need to make sure the next letter grade isn't referring to the same location. Now we can finally return the result. If the for loop finishes without ever returning a result, this means all 40 of the classes were in the last grade, so there was nothing to change, and the iterator is finished. There are a few small things we need to fix that I skipped over. Tuple windows clones the values before returning the window, so we'll need to derive clone for letter grade. Also, when we index the enum map in grade counts, it expects a value, not a reference to a letter grade. Because we have to do so much cloning for letter grade, and it's just an enum, we can derive copy on it for implicit cloning. We also do a comparison with letter grade, so we'll need to derive partial eq as well. Finally, when we return the grade counts, we need to clone the value. We can't return a reference because we mutate it on every iteration inside the iterator. Here's a simple script I wrote to help confirm that it works. It just counts the length of the iterator. When I run the script in release mode, after about 5 seconds, I get this number. 2,054,455,634, which I checked and it is correct. That's about 30 orders of magnitude less than the total amount of combinations in our previous solution. Now to finally get the answer, we'll add two methods to our grade count struct. The first one calculates its GPA, the second calculates the absolute difference from the GPA to pi. Going back to our main function, we'll iterate through each value, find its distance from pi, represent it with an unsigned integer for faster computation, and find the minimum value. After about 30 seconds of waiting, this is what the console prints. So if you get 31 A's, 1 C-, and 8 F's, your average GPA can be 3.1425. There's actually a very easy formula to figure out the solution instantly, but it's math and we do computer science here. Also, I know my code could have been quicker. I didn't even parallelize it. I'll leave it as a challenge to the reader to optimize the process.